Energy prices are only going in one direction, up. And it feels like data centers and storage devices are what's sucking so much of energy for your corporation. Yet when you start trying to make your data center more efficient with your storage devices, it feels like you're untangling this extremely complex web of different devices with different needs and different types of data. Today, I'm going to cover for you 4 different categories of energy statistics with 5 different statistics to look at from a storage, sustainability, and energy perspective. I'm then going to close the video with 4 different types of drives and where they fall on the scale typically from energy efficiency to low power when you're evaluating them. So let's dive right into the statistics that matter when you're trying to get energy efficient storage infrastructure. First, let's start with the obvious one. There's overall energy that a device consumes. Not all devices are created equal, and the first thing you often look at is how many kilowatt hours that device is consuming. But this is often where people start and end their energy conversation, which leads to a lot of different devices that aren't always getting used for the right use cases, and therefore your overall data center ends up with a lot more energy. The rest of these statistics give a bigger picture to the energy efficiency conversation in storage and help you evaluate exactly what you might need, particularly in those use cases that need higher performance, higher capacity, and therefore use more energy naturally. Let's start with the next one. You should be considering your capacity with respect to how much energy you use. The statistic for this, or metric, is terabytes per watt. Here, you will be able to look at the system that you're trying to design and scope for and understand exactly how much density you can get per terabyte per watt. The next statistic is along the same lines, but more with a performance focus. When you are looking at use cases that need to be extremely high performant for you, it's really important to understand how efficient those are going to be from an energy perspective. And in that case, you should be looking at IOPS per watt. The next thing is a little bit more of the big picture, which is really what is built around the actual storage device. This is the environment that is used as far as infrastructure to support the storage device from an energy perspective. There's 2 key metrics to consider here. The first is the operating temperature. Overall, at what temperature does your storage device need to be cooled down to perform to its metrics? If that's extremely low, then you're going to have a lot of overhead cooling energy consumption in your data center. The second key metric is exactly how dense the storage device is in your environment, or the watts per U. Overall, if you have denser storage devices, you take up a lot less space in your data center and therefore a lot less space to power, a lot less power infrastructure to make, a lot less space to condense down into cooling. Really great things to consider. So overall, these are a lot of the key metrics to consider when thinking about energy efficiency in your storage devices. Now I'm going to talk about the different drive types and where they fall on the scale from look at it from an energy efficiency perspective versus look at it from a low power perspective. So some devices are lower on the performance level and have better density per watt versus some devices are higher and have better performance per watt. Depending on your use case and how quickly you need to access that data, you should consider these different drive types. First off, on the lowest power option, we have tape. Tape has been around for a while, but from an energy perspective, it can be a lifesaver when you're just trying to archive data. You can turn it off between writes and reads, and it will sit there and store your data without that overhead energy cost. The next thing is really storage class memory, or in general just memory. This is really getting at some high density, but also high power. So it's a great option, but perhaps not the most performant option in the market. The next is HDDs, or hard disk drives. Hard disk drives, again, you're getting closer to an energy efficiency level. They're having more power, but they're not the entirely most performant. And the highest level are SSDs, or solid state drives. These are going to give you these flash networks in the drive themselves to be the most efficient possible. And if you have high performant workloads to use these drives, they're a great option. Within each of these, I would also consider, once you've got your drive type picked out, to shop around in the market. For example, some corporations have their own innovative SSDs or flash drives that do better from energy efficiency perspective than the industry standard options. That's worth looking at when you're evaluating the total cost of ownership and the total energy that your data center is consuming. This is an overall first look at how to make your storage devices and overall data center more energy efficient. Thank you.